So I'm going to go ahead and pick up where we left off with the rules. These are the rules you need to know, the exponential and logarithmic. There's a relationship between these, so let's not just memorize these. We know that if we have, let me change the color here, if we have b to the x times b to the y, that we can add the exponents, b to the x plus y. Well, the result of a logarithm is basically an exponent, so here we have exponents or logarithms that are being added. Well, here multiplication turns into adding. Here we can change this adding into multiplication. So there is basically a relationship, an inverse relationship between exponentials and logarithms. On the exponents quotient, when I'm dividing 2 with the same base, we can subtract the exponents. Here, if I'm subtracting 2 exponents, I can divide the x and the y. Okay? On the right here, on the left here, sorry, we're at the power rule, b to the x to the y, exponents become multiplication. Over here, this multiplication, this x, can be brought up and become an exponent. Both of these go back and forth. Everything on the left side here is called expanded form. So I guess everything right here in the middle, this is the expanded form, and anything on the right we call condensed form. So you're going to want to have that written down, but it's not a new set of rules. I do warn you just to be careful. Do not expand log of x plus y. That was not one of our rules here, so don't start making up rules. If I have log of x plus y, it is already simplified. Now, to expand on this, what I would do is I would encourage you to learn how to read logarithms with meaning. And this is where I think a lot of people kind of miss logarithms and think they're a lot more complicated than they really are. Because if I read this log base 2 of 8 equals x, that's terrifying. Log base 2 of 8 equals x. You're like, I have no idea what that means. That sounds terrifying. Well, it would be like to me when I walk to my 6-year-old, 7-year-old daughter and I say, what's the square root of 25? I have no idea what square root means. That's utter nonsense. Now, if I said what times itself makes 25, and you go, yeah, I could do that. But the square root has no meaning to her because she hasn't been introduced to it yet. So when I read log base 2 of 8 equals x, if that's utter nonsense to you, you need to learn how to reread these. Log base b, the b there is the base, of the y, the result, is equal to the x. The result, or the answer to a logarithm, is really an exponent. That's why, the answer to logs, here's the exponent on the side. This basically says b, the base, to what exponent x makes y. This now doesn't intimidate me as much because I can say the base, so that's green. This is scary. This I read and I go, I have no idea. But if I took the base and I said 2, fill that in, to what exponent makes the y is the result. Here the result here is the 8. 2 to what exponent makes 8. I would look at this and go, yeah, 2 to the third, x is 3. And you'd be right. So when I look at these, let's go ahead and read them with meaning. Log base 3 of 1/3 equals x. That's not meaning. What's the base? Well, we said the base was this number down here, so that's 3. To the exponent, we don't know. What exponent? All right, makes 1/3. If I said what's log base 3 of 1/3, and you're like, I have no idea, then you need to learn to read that. 3 to what power makes 1/3? That would work if x were about -1. 3 to the -1 would give us 1/3. Next one, log base x of 4 equals 2. What's the base? This time it's x to what power? To the second power. Makes the result 4. So this really says x to the second power makes 4. Well, we could solve this. I'm doing the squaring. We would say x is equal to plus or minus 2. But you'd be wrong here. That's, once again, just kind of learning about logarithms and learning the rules. It's not that the answer is not 2. The issue is that the answer is not -2. The answer here, x would just equal 2. You're like, well, why? I thought it could be a plus or minus. Well, logs always have a positive base, which makes that negative solution extraneous. You're like, well, why? Why can't they have a negative base? Because we don't need it. When we're dealing with bases here, we're dealing with positive numbers. So we are not needing negative bases, and we don't just do math for the sake of doing math. We don't need negative bases, so we don't use negative bases. So that actually makes your life a little easier. This one says what? The base to what exponent makes what? 5 to what power is 1? You should be able to answer that. This says 5 to the 0 power makes 1. That means our power is 0. And last, what do we do if the 5 and the 2 are known, but the x, the result, is what we don't know? It's actually easier. Log base 5 of x equals 2 sounds scary, but what's our base? 5 to what power? The exponent was on the outside there, equals the result x. X is what? X is about 25. So I hope this is a bit of an aha moment, because we don't need to make these scary. We just need to learn how to reread them. Log base b of y equals x is the same thing as saying the base to the x to the exponent is equal to y. And this is called logarithmic form on the left. This is called exponential form on the right. A lot of teachers will start by giving this to you at the beginning and say, here's the trick. I think it makes a little more sense to actually stop and read it out with me. So that's what I would encourage you to do. Let's do a little bit more practice. What is log base x of x? Read it. X to what power makes x? X to the... You should be able to now solve these. What's this one? X to what power makes 1? X to what power makes 1? That would be x to the 0 power. We should be able to check these. X to the first power is x. What's this one? Anything to the 0 power is 1. These are a couple of our rules. You don't have to memorize them if you read them with meaning, but whenever I have the base and the result the same, the exponent has to be 1. Whenever I have the exponent of 0, the base is x and the result is 1, the exponent has to be 0, because anything to the 0 power would be 1. How do I do this one? X to what power makes 0? We already did x to the 0 made 1, so x to what power would give us a 0? Well, we said this isn't going to work, because remember, I need my x to be a whole number, and if I raise it to a power, it's never going to become 0, so this actually has no solution. X to what power makes negative 1? Well, we already said, if the base is 10, the exponent, if the base has to be positive, and I raise it to an exponent, it will never be negative. This also has no solution. Log base, and if you don't like that, there's an easy example. Let's just choose an easy base. What is log base 10 of negative 1? 10 to what power is going to make a negative number? If I multiply by 10 or divide by 10, will it ever become negative? No. This has no solution. If the base is positive, which it has to be, then this result can never be negative. So this comes up with a couple rules. So the domain x cannot equal, what did we say? If I have log of x, what can't we put inside a log? We said we can't put in a 0. And we said we cannot put in any negative numbers. Which means what? It has to be positive. X must be greater than 0. When we go to graph, when we go to deal with logarithms, that result inside the logarithm must always be greater than 0. It cannot be 0. It cannot be negative. Let's keep going. What does this say? Well, what's the base? To what exponent makes what result? Base, exponent, result. Just using, where do we go? Just using these right here. That right there. learning to read it, I can solve these very quickly. Now the actual solving of this is going to be a little trickier, but we did this in the last section. 8 and 4 can both be written as base. 2, 8 is 2 to the third, 4 is 2 squared. Now that they have the same bases, we can solve it by setting the exponents equal and x is equal to about 2/3. This one, what is the base? What is the result? Exponent there equals what result? How are we going to do a fourth power? We've done this before. So that x is equal to, normally with an even root, we would have a plus or minus 16. But remember, this base cannot be negative, so we cross out the negative. It's extraneous, and we're just left with positive 16. And last, 4 to what power equals x? I think we could simplify that. That is the same thing as 2 is the root. So how about the second root of 4 to the third? The square root of 4 is 2 to the third. So that x equals 8. You also need to know, if it is in condensed form, how to expand it. For now, this is going to seem like we're just doing it for the fun of doing it, but in the future, we are going to have some really neat applications for this. But for now, what you need to know is any multiplication turns into addition, any division turns into subtraction. So on the top, I have a 2 times x. I look at this and I see 1, 2, 3, 4 terms. Anything that's multiplying or dividing creates a separate group. So when we expand this, it will expand into 4 separate logarithms. The 2 is positive on the top, stays on the top. The x is multiplying on the top, stays positive. The y and the z are both dividing. So I know I'll have a y, I know I'll have a z. The fact that they're both in division means they're both negative. And we would keep that base a on every little of these suckers. Here's the issue. Somebody's like, well, why are those negative? I thought multiplying became adding. Well, it does. Technically, this yz, since it's being divided, would be the same thing as minus log of y plus log of z. That multiplying would become adding, but the fact that it's all in the denominator means this negative would distribute, making them both negative. I think it's easier just to say if it's on the top, it's multiplying, positive. If it's on the bottom, dividing, negative. How do we expand this? Well, if there's no base, you need to know that that base is base 10. We don't have to write it, but we do need to have that. That's something you should know. If there is no base, the base is 10. It's a fact we should know. So when I expand this, first thing I'm not liking is on the top, these are grouped together. Let's see if we could deal with that. This is the same thing as, both raised to the, so now I can use the exponent rules and get x to the 2/3 and y to the 1/3. So now I'm thinking of this as log of x to the 2/3, y to the 1/3, over z to the 3rd. I see 3 separate terms. I will separate that into 3 separate logs. First one is x to the 2/3 plus y to the 1/3, they're both on the top, minus z to the 3rd on the bottom. You do have to recognize this time this is not expanded completely. Why not? Well, we said these exponents can be expanded. It's one of the points of logarithms. Exponents can be expanded into multiplication. So basically each of these can travel to the front, giving us 2/3 log of x, 1/3 log of y, minus 3 log of z. And that would not be expanded completely. This one is expanded. We're going to need to condense. We're going to go the opposite. So what we're going to do first is we're going to deal with the exponents. Any multiplication in the front, I cannot condense these logs unless the logs don't have that number in front of them. We can deal with that. Each of these can become an exponent. Each of these can travel up. So this becomes log of m to the plus log of 2n raised to the 3/2 minus log of m squared n. Now that I have the logs with no numbers in front of them, they can condense into a single log. What do we have on the top? M to the 1/2. Here we have 2n to the 3/2 over m squared n. Here's the bad news. We gotta clean this sucker up. I can't have m's on the top and on the bottom. So here's what we're gonna do. Let's start with m to the 1/2. I'll leave that. No, we can deal with that. This is basically what? 1/2 on the top, 2 on the bottom. We can use the subtraction rule. This is m to the 1/2 minus 2. 1/2 minus 2 would be negative 3/2. We will eventually move that back down to the bottom, but for now I'll leave it at that. This 3/2, I'm going to end up with 2 to the 3/2 times n to the 3/2 all over n. We can cancel out the n's. N to the 3/2 minus 1. That looks like we're going to end up with just n to the 1/2 on top. So now we'll clean it up. Log, we're not going to leave a negative exponent, so I'll leave that n to the 3/2 on the bottom. 2 to the 3/2 here, and this becomes what? N to the 1/2 here. And I'm actually fine with that. I would leave it just like that. It ain't pretty, but that's what we have. Technically, I could look at this and say, oh my gosh, these all have a denominator of 2. So I could stick all of this under a square root and end up with 2 to the 3rd, which is 8, n over n cubed. Well, maybe that is actually easier to look at. So just a thought there. Those denominators could become a square root for all of them. Choices. I think I do like that better. And going back to where we started, what's the whole point of this? How do I solve 2 to the x equals 5? Right? Currently, we can't. We don't know how to do this, but that's where our next section is leading. How do we undo an exponent? What we've been discussing from the very beginning, the inverse of an exponent is a log. So we will solve this by logging both sides. What does that do for us? Well, the expanding will say that x can now travel to the front. So instead of x being an exponent, instead of x being exponented, it is now multiplying. And we can undo that multiplying by dividing. And I can do this in my calculator. I can type this in and hit enter, and it will give me an approximate answer about 2 point something.